And now we can solve this thing. Well, we can start to solve this. So the function signature looks like this. So let's create a new entry here. This is problem number 21. Pub mod lc 0021 merge to sorted lists. Yeah, we're going to be very descriptive here. And then we'll say edit, source, and then we come back over here, copy and paste. And this is going to return none just to get it to build. Oh, right, and list node doesn't exist, so we have to say use create list node. That should work. Good. And now we write our first test. Example 1. How many examples are there? There's 3 examples total. So let's just get the first example to pass for now. Test mod, expand, test, expand, x1. So now we have 2 lists. So we should be able to say this, right? Let list 1 is equal to, and I should just be able to use the same the code we just created, list node from vec bang 1 2 4, and then list 2 is 1 3 4. Let's delete that and see if we can. So that builds, and now we have to merge them. We'll call merge 2 lists. And we need a merge 2 lists, list 1 and list 2. And then we need to check them, right? This should be an option box something something. And then we need, the result should be 1 1 2 3 4 4. So let's create a check array, check is equal to vec bang 1 1 2 3 4 4. Let n equal 0. While would basically do the same thing we had before. Let some entry equals merged, which means merge needs to be mutable. We're going to assert eq that entry.val is equal to check of n, right? And then we say merged equals merged, entry.next, right? And that'll keep looping until that's none, and so it should verify that we actually have something. So this should fail the test. Help remove this mute. Oh, right, I forgot to increment n. Negvorsa says n plus 1. Yep, I got it. What's bothering me now is that I'm not seeing the test fail. Huh. Why is the test not failing? Because this is returning none. Oh, I got to verify that n assert eq n is equal to check.len. And that way we know when we went through the entire list. Yeah, so now it fails. Okay, good. So now we just need to write the actual merge code. How hard could that be? I guess we can start off by, we can just merge it into a brand new, or should we create it, put it in an array, and then after we've generated the array, then we can create, it says the merge 2 lists into, the list should be made by splicing together the nodes of the first 2 lists. Are we assuming that the first 2 lists are already sorted? Yes. So if they're already sorted, that makes things a little bit easier. Prideness, thank you for the follow. Very much appreciated. Welcome to the stream. So if they're already sorted, then we can just look at the first two and then see which one is, or we just convert it to an array, a vec, and then work our way through the vec, because that might be easier. Here's what I'm thinking. So this should be like while list one, not list one, is none, and not list two is none. Then we'll grab the first entry, let E1 is equal to list1 dot unwrap, and that should be an entry, a box list node, right? Let E2 is equal to list2 dot unwrap. If E1 dot val is less than E2 dot val, then we're going to create a result thing to push things onto. Oh, right. And that's why we want to do this. If we do this in reverse order like we did the other one. Yeah. So we need to actually, yeah, if we're going to do this in reverse order, we have to reverse the lists. In order to reverse the lists, we have to convert them. Okay. I guess we do it that way. New. Actually, I can create a little function which does this, but list one. And then we say while let some entry is equal to L1 pointer array one dot push entry dot val, and then we can just reverse them. Array one equals array one dot reverse. Iter reverse. Collect. Can we do that? Apparently we can. And we do the same thing for array 2. And this is L2 pointer, list 2, L2, and then we have these two arrays. So let's print these out. Println array 1 and array 2. We'll get rid of these things. Let's see what that looks like. Oh, we can't do that. Can't be built from into iter. Right, and we'll have to do the same thing with this guy. Implicitly returns none. Let's do none, or unit rather. Value moved here in previous iteration of the loop. Oh, I have to say L1 pointer is equal to entry.next. And L2 pointer is equal to entry.next. There. Okay, so 421, 431. So we have reversed arrays. Blue Smoke says example 2 has two entries that are both empty lists. Ah, you're right. So we would have to we'd have to check for that. Okay, when I write this test, I'll add that code to there. But thank you. Yeah, that's a good point. We should be doing that when we get to example 2. So now we have these reversed arrays, so we can build these lists in reverse order. I guess it would be nice if like the list had an append option for it. Like if you created a list node and you say, oh, just append this to the list. But I don't have that. So we're going to do it the sloppy way. So now we're going to walk our way through the arrays. So we need two array indices. I1 equals 0. I2 equals 0. Let node equals box new, because these things are in boxes of a list node, and we have to choose which list node to use. So we say if array 1 of I1 is greater than array 2 of I1, right? Because we're building it in reverse order. We're going to say we take the larger value, and I1 plus equals 1. And then we're going to return a list node of next with none. We're just building the final element right now, and the val has array of I1 minus 1. And I have to do it this way. Oh, that goes here, and then this goes here. Else, because we're going from the last. So I'm starting with our final node, and then I'll create a little loop, which will determine what nodes to add to it. Right, and then list node next is none. Val is array 2 of I2 minus 1. Okay, so that's our first node. Does that build? It doesn't. I forgot to close it like that. Okay, I reformatted everything. And now we can say while I1 is less than array 1 len and I2 is less than array 2 len, we'll determine which one to do it. So it's basically the same exact code, except now we're going to put a node in the place of next. We say node equals this, and this next is going to be, this is where the node goes. Oops. Nope, there. All right. Does that loop build? Oh, right, it has to be a sum. Nagvorsa says, I think it's better to have the result as a vect and put the merged value there at the end of the convert to list. That's smart. See, that would be a smart way to do it. Right, instead of building the list this way, we build the vector. Oh, that way we wouldn't have to reverse these arrays and all that kind of stuff. Yeah, let's do that. We'll just create an array of I32. Let mod vec vec result is equal to vec new. And now we can say while this line here if, yeah, and then we say vec result push the smaller of the two, right? If array 1 I1 is less than array 2 I2, then we're going to push 1 since that's the smaller. So I1 plus equals 1, and then we return array 1 of I1 minus 1. Else, we do that. Change all these to 2's. And then at the end we need to clean up, right? Because there might be entries still in I1 or in I2. So we have to say while I1 is less than array 1 len, vec result push array 1 I1 plus equals 1. And then we do the same thing for I2. Yeah. And now we can just say return list node from vec result. Will that work? Nope. These are semis. Tafir, thank you for the follow. Array 2. So you said array 2. Yeah, I got array 2 here, right? Did I miss an? Oh, I did miss an array 2. Thank you. But it still doesn't like this. Not found in the scope. Oh, I deleted those lines. That was dumb. There we go. And the test passed. Where is it? There it is. All right, now we're going to get to the The one that Blue Smoke pointed out. Let's do the empty list test. So that means we actually have to create two lists that are empty. Oh, how do you create? Oh, just none. We'll just pass in none. Let mot merged equals merge two lists, none, and none. Super simple. Oh, die. I don't know how to pronounce your name. Please let me know. Tafir says the last while loop also has array 1 instead of array 2. Oh, thank you. I'm probably going too fast, right? I'm just ignoring all that stuff. But thank you for that. So now we should say the merged list should be none, right? There shouldn't be anything. It should output this. So we will say assert merged is none. And this should fail because we don't have a check for this. Oh, it doesn't need to be mute. And oh, it is none. How is that possible? So let's see. So this array is going to be empty. This array is going to be empty. We'll skip over this. We'll skip over this. This vec result is going to be an empty array. Okay, so maybe from vec that handles all that for us. If I take a look here, yeah, let result is none. We loop through the array, building the list, and then return result. And of course, since vec is empty, we don't do any of this. So we do a lot of work. We could short circuit it up here. Should check to see if list 1 and list 2 are both none, then skip it. But this seems to do the trick. Let's do our final example with a none and a 0 and see if we get a 0 output. EX3. So this should be let merged is equal to merge two lists of none. And oh, we have to create the list. Let list 2 is equal to list node. Oh, we can just say list node new 0. Just like that. Dr. Persona non grata, you are welcome here. Thank you for joining. And we just passed list 2, and now we should be able to say assert eq merged dot unwrap, because it's an option, right? It's an option of a boxed list node dot val is equal to 0. And we should be able to say assert merged dot unwrap dot next is none, meaning there's only one entry in the array and it's 0. And this failed. Expected enum option. Oh, right, this needs to be an option box. New list node this. Negvorsa asks, can we do it without creating array 1 and array 2? Can we? We can look at... Yeah, the reason I was doing the arrays initially was because I needed to reverse. But you're right, we do have list next. Well, let's see if this solves the problem. Let's see if this solves the... let me fix this. See if it solves the problem, and then we can go back and refactor. Maybe we can. Maybe you're right. We can have a pointer. We can walk list 1 and list 2 one by one until they're none, and then do the same thing we do here, except without the arrays. Let's try that. But first, yeah, this expected enum option. Okay, I solved this. All right, let's try again. Oh, this fails. Move occurs because merged has type this. Oh, right, this asref thing. Excuse me. I'm just coming off a cold, and so I was doing fine up until now. Okay, so that worked. Let's see. Let's try to do it without the need for arrays. We can create a vec result still. Oh, right. I wanted to see if this did the trick, right? Let's copy and paste this code over. We'll put it in here. And again, we have to shift everything over. Oops. Did I miss a... I did. I knew that looked funny. There we go. All right, so let's see if this works. If this works, then we can refactor with the without the arrays. Ooh. Oh, right, there is no from vec. So we have to actually copy and paste that over. Let's do that. There. Okay. Does that do it? And get rid of that line. Let's see what happens. Ooh. Oh, it's not called vec anymore. It's called vec result. And it's no longer self-new entry, is it? It's a list node. Oh no! I have to try it again in a few seconds. Okay, I'm going to have to remember that for next time. 5 milliseconds, 21% faster. Faster than 21% of other submissions. So this is kind of slow. Let's see if getting rid of that array business will speed it up. So we can say while. Ooh, yeah, you can't do a let. You can't do a double let sum. So you can say let mut. Okay, here we have to check. If list1 dot is none, then we return list2. If list2 is none, return list1. And now we know that list1 and list2 have at least one entry each. So we can do an unwrap. L1 is equal to list1 unwrap. Let mut L2 is equal to list2 dot. Wow. Unwrap. While L1 is sum and L2 is sum. If, and we want our vec result here, right? If L1.val is less than L2.val, then we're going to say vec result.push L1.val, L1 is equal to L1.next, else vec result push L2.val, L2 is equal to L2.next. And then we still need to do the cleanup, which is this code here. While let some entry is equal to L1, right? I think so. Vec result push L1.val, L1 equals L1.next, and then do the same thing. And this time I'm not going to mess up my 1s and 2s. Got them all? Okay, and now we have a vec result and we can do this. Okay, let's see if that compiles. It does not. Method not found in box list node. Oh, right, because these are no longer options. We don't want them to do this. And now we have to unwrap the val. All right, well, it's getting a little complicated, but... And then we're going to need to do as refs in there. Okay, so that all worked. Well, we don't know. So now we need to do, oh, this is entry. All right, that makes that a little bit simpler. We don't have to do all the unwraps there. And now we have to do the as refs, right? And this doesn't work. Why? L1 moved to due to this method call. Oh, do we have to do as refs there? Okay, so we should just L1 ref, L1 as ref, unwrap val, and an L2 ref. And then we can just say if L1 ref is less than L2 ref, and we can just push that. It should actually be val, not ref, but okay. Blue Smoke says, what about a shortcut at the top if list 1 is none and list 2 is none? Right, so if list 1 is none and list 2 is none, this will just return none right there. So this kind of does that shortcut automatically for us. Maybe I went too fast with it. If I do this, if I say if list 1 is none, oops, I said 1 and I typed 2. And list 2 is none, return none. I still need this line because if list 2 is not none, then we're going to return it here. But if it is none, we can just use this as a kind of a shortcut. So let me add a comment there. If list 2 is none, we just return none anyway. Does that make sense? So this is already kind of a shortcut for that. And amazingly, all the tests passed. So let's copy and paste this code in and see if it's any faster. I'm not going to paste in there because that's our code generator. Let's do this, paste, and submit that and see if it's any faster. So Alicia says, but that's not necessary. If list 1 is none, that doesn't imply that list 2 is also none. You're right, it doesn't. So if list 1 is none and list 2 is something, then we're going to return list 2, and that'll just be the answer. Oh, look at that. It went a lot faster that way. Negvorsa, you just sped up my code by 40% there. And Negvorsa asks, can we do a compare and create the result as a list and get rid of the result vect? We would have to walk this in reverse order in order to create the list the way. The way it needs to be. So I don't think we can do that because we have to do this. We would have to do this backwards. Yeah, comparing greater than, right. So that would generate the vec result or the list backwards, and then we'd have to reverse it forwards. Right? And I must be misinterpreting what you're saying then. So Alicia says that they misinterpreted this comment. Yeah, so maybe that comment is not helping. I'll take it out. I'll say list 2 might be something or might be none. Either way, we can just return it here. And then if list 2 is none, then we don't have to return list 1. We can just return none. Oh, no, we want to return list 1 because list 1 is not none. Right. So Negvorsa, I don't think I understand what you're getting at, unfortunately. If you want to, I don't know if you're on Togglebits, Discord, but I hang out there too. Maybe you want to hack together some code and paste it there, and then we can take a look at it. Or if you have it up on a GitHub, I can take a look there. But I think this is going to be my answer for now, for merge two lists. I'm going to say that I've got it done. Let's see, git status. What do we change here? Git add source, git commit. Which problem number is this? Description. 21. Oh, I should have been able to see that here. -m problem 21 merge two sorted lists. Good. All right, I think I have time for one more.